Consider a situation wherein in class there are many children and out of them few children raise their hand and ask their teacher some question. Teacher can handle this. She can answer the questions of few students. But think about this. What will happen if all the students suddenly raise their hand and then they ask some random question related to the topic or out of the topic? Then what will happen? This, in terms of computation science, is known as denial of service attack. So denial of service attack is something in which we request the server so many things that it is unable to serve all the clients. Here our students are denoting the requests and the teacher is denoting the server. So this is the scenario, like all the children are bombarding questions for the teacher. Let's see how we are going to solve this problem when we are designing our systems. Welcome to the second lecture in system design series, wherein we are learning how to design scalable software architectures. In this video, we are going to design a rate limiter. Let's dive in this together. Before we start, I am learning system design through this book. If you want, you can get a copy of this book from the link provided in the description. Okay, so in this video, we will try to understand the problem and we will try to define the scope, what is a rate limiter and what type of rate limiters are available, and on what basis we will do the rate limiting. We can do the rate limiting on the basis of IP, on the basis of user, on the basis of different transactions, and how we will scale this rate limiter in the distributed environment. Then we will see where we want to put in this rate limiter in our architecture. And then we will dive into 5 different rate limiting algorithm: token bucket algorithm, leaking bucket algorithm, fixed window counter, and sliding window, followed by sliding window counter. Then once we are done with algorithms, we are going to drill deep in the design. We will have a look how we can inform the users when they are rate limited or are being throttled. Then we will have a look on the detailed design and how this system will work in distributed environment. After that, we will have a wrap up of everything that we are going to discuss in this video. Okay, assume that you are working in Twitter and then some software engineer writes a script and he is sending lot of tweets in single second. So your platform will really become messy. All the followers of that person who has written this script will get lot of tweets. So to stop these kind of situations, we need a rate limiter. Second use case is, let's say you have a couple of EC2 machines behind a load balancer and you have turned on the auto scaling on. Now some user knowingly or unknowingly can send so many requests so that your architecture or infrastructure will scale up and it will cost you so much of money. So to save such kind of situations, we need a rate limiter. Third use case is, when someone is trying to log in onto your website, they can randomly try different username and password on your website. To stop people doing this or to throttle them, you need to implement a rate limiter. Now we understand the problem and couple of use cases wherein we can apply rate limiter. Now we understand the problem, let's scope the solution. Like what kind of rate limiter we are going to implement. We are going to implement it on the API. On what basis we need to rate limit the users or the clients? On the basis of user ID, IP addresses or something like that. Let's say we want to create a rate limiter which can be extended to limit on the basis of IPs or on the basis of users. And this can be scaled across the world in all geographies. Now question comes where to implement the rate limiter. It can be either implemented on the client side or on the server side. So assume that your company creates SDKs for integration in different websites or in mobile application. You can create a rate limiter in the client side or you can do the rate limiting on the server side. These are two places where we can implement the rate limiter, but recently with the advancement of infrastructure and cloud technologies, there is one more thing wherein we can put on the rate limiter. It is known as API gateway. API gateway is something which can be used to implement authentication, throttling, or serving static content to the client. So let's see how we can implement the rate limiter on our API gateway. Now let's dive deep into the different algorithms that we have. So first one is token bucket algorithm. Assume that our teacher implements one rule wherein if you want to ask any question to the teacher, you will have to pick a coin or pick a token from this bucket and then hand over that token to the teacher. Then only teacher will answer your queries. And near the door of the classroom, this bucket is there, and this is refilled by the security guard on a particular time interval. So this is token bucket algorithm. Following this algorithm, our teacher is not bombarded with all the questions that she was facing earlier. Now let's see how we are implementing it in computational way. Over here, what we are seeing, if some request is coming in, we will check whether our bucket has enough tokens. If enough tokens are there, we will attach the request with one token and then forward it to the servers to send a response back. If no tokens are there, then request will be dropped. This is how token bucket algorithm works. Now this token bucket algorithms, when we are implementing it, it takes two parameters. First is bucket size and another one is refill rate. Bucket size is how many tokens are available in the bucket, the maximum number on a particular period of time. And what is the refill rate? Number of tokens put into the buckets every second or every minute. Depends on how we are implementing the token bucket algorithm. Moving ahead, the next algorithm that we have is leaking bucket algorithm. Leaking bucket algorithm got the inspiration for its name from a bucket which is having a hole in the bottom of bucket. So it doesn't matter how fast we are filling the bucket, the drips or the outlet of the bucket will remain same. If this bucket is full and we continue pouring the water in this, the water will overflow and it will not go into the bucket. So these algorithms take inspiration from this concept, and you can think of in this way. When our teacher wants to implement this in the leaking bucket algorithm, you might have seen these kind of cup holders wherein every student has one cup and they will have to write their question in this cup and then they will have to put in this cup holder. And what our teacher will do, our teacher will take these cups one by one, pick the questions asked by the students and she will answer it. Now let's say if there is some student who wants to put in the cup, when this cup holder is full, they will not be able to add the cup to this cup holder. That's the whole idea of leaking bucket algorithm. Now when we are implementing it computationally, what we are going to do, we are going to implement one queue, and in this queue we will check if the queue is full or not. If the queue is not full, then we will put the request in the queue, and if the queue is full, then we will drop the request, and these request goes to the server at the fixed rate and server respond back to the client. Leaking bucket algorithms take two parameters. First is bucket size, how many requests we can save in this queue, and what will be the outflow rate. And by outflow rate we mean how many requests can be processed at a fixed rate, usually in seconds or in minutes. Okay, let's discuss the next algorithm, that is fixed window counter algorithm. In this algorithm, we define how many requests we are going to serve in a particular period of time or in a fixed window of time. Let's say we define we would serve 3 requests per second. So what will happen? Let's say at this particular point of time, if 3 requests are coming, we will serve them, and if 6 requests are coming, we will serve the first 3 and the next 3 will be dropped, or they will be throttled, or they will be rate limited. Similarly, if 4 are coming, we will throttle the last one, and if 2 requests are coming which is less than 3, we will serve both. With our analogy of our teacher and student, our teacher is saying, okay, I am going to answer only 4 people in an hour. So what she does, she asks a student to come in groups every hour, and if they are in less than the threshold value, whatever our teacher has set, she will serve or answer their queries. If not, she will say, okay, reduce the size of this group. And then what will happen? A student who is coming last in that particular group will be dropped off. One problem with this algorithm is at the end and starting of different time intervals, this algorithm can serve a spike of the traffic, and this algorithm takes two parameters. First is window size and what is the maximum number of requests that we should serve. Okay, let's talk about the sliding window log algorithm that we can use when we are designing rate limiter. The idea behind sliding window log algorithm is we write the timestamp of each and every request that we are serving. Let's say we have a rate limiting rule which says we are going to serve 2 requests per minute. So assume that at this timestamp 1 hour 0th minute and 1st second we are serving a request, it goes through, and in the same hour some request is coming in at the 30th second, it will also go through because it is the second request in a window of 1 minute. Now let's say there is one request which comes at or which arrives at the server at 50th second. Now according to the rate limiting algorithm, we will see what was the last logged in time for a request. So it was 1 and 1, and it has not expired because 1 minute has not passed. So this particular request will get blocked. Now let's say the times move ahead and we get another request at 1140. We will see what are the different timestamps for the last two requests. So for last two requests, the timestamp are 150 and 130. 130 already lies outside the 1 minute time frame or 60-second time frame, so it is crossed away. So when we count that what is the number of this request in this minute, it turns out it is the second request in this minute, so it goes ahead. Now when we see sliding window log algorithm in form of the analogy that we are taking as an example, so let's say one student comes at this particular timestamp 1:1, teacher will answer this student's query, and second student comes at 1:30 seconds. Teacher will answer his queries because she is going to serve the second student in last 1 minute. Now let's say there is one more guy who comes at the 50th second. Now teacher will see, okay, in the last 1 minute I have already answered 2 students, so she will not answer the student's query. Similarly, when a student is coming at the 40th second of the next minute, she will know, okay, she has not served or she has not answered 2 students in last 1 minute. So she will take this student's question. So sliding window algorithm takes one parameter, request per time amount. So let's say if I want to define 2 requests per minute or 200 requests per hour, so these kind of parameters can be given to sliding window log algorithm, and this algorithm is very accurate in terms of limiting the clients according to the defined rules. The next algorithm that we are going to discuss is sliding window counter algorithm. This is an algorithm which takes best features of fixed window counter algorithm and sliding window log algorithm. What it essentially does, it puts a slider on the fixed window counter algorithm. Let's see how it does. Let's say we are currently on this time, and when we are computing the rate limits, we will see how much the time has elapsed in the previous time frame and how much time we have consumed in the current time frame. In this algorithm, the rate limit is computed using this formula, request in current window. For example, in current window we have served 3 requests, plus request in the previous window. In the previous window, we have served 5 requests multiplied by overlap percentage of the rolling window and previous window. So overlap percentage is 70%. Using this formula, we get 3 plus 5, 3 and 5 requests multiplied by 0.75%. When we summarize it or when we solve it, we get 6.5 requests. Depending on the situation or use case, we can either round up or floor it down. So here we have discussed 4 algorithms to design rate limiter, and we are good with one of them according to the different use cases. Now the high level design of our rate limiter would be from the clients. The request will come to a rate limiter middleware, which is essentially an API gateway. And this rate limiter will save the different parameters of these rate limiting algorithm in one Redis server. And if this rate limiting passes through, it will forward the request to API servers. Now let's talk about different elements when we are diving into the different aspects of our rate limiter, like how our rate limiting rules will be created and where we will save them, and what we are going to do with the clients that are rate limited, how we are going to tell them, and how this rate limiter will work in distributed environment, and how we can monitor our rate limiter to improve the parameters. So when we are talking about creating and storing rate limiting rules, it can either be created in text format using YAML or XML on the file system or in some databases. And when we are saving in database, we can create very good UI in form of some web portal. This particular screenshot is taken from AWS. In AWS, the rate limiter looks like this. Now let's talk about how we are going to handle the rate limited clients or request. Generally, there are two things. First, we can tell the clients through HTTP headers and HTTP responses when they are rate limited. Different companies implement different version of HTTP headers, namely X rate limit and X rate limit remaining. You might see GitHub implements a continuation of rate limit, whereas the Twitter implements rate-limit. And these kind of HTTP headers are not standards because IETF, the Internet Engineering Task Force, is still working on this draft which will standardize all these kind of headers. And once these headers are standardized, we hope that we will see a standard set of HTTP headers across different implementation by software companies. These are some headers that we can implement in our rate limiter as well. And when the client is rate limited, we can send back 429 HTTP response code, which means they have requested too many requests. They have done too many requests, and we can hint them after how much time they should do a retry on the same endpoint. If you want to learn more about HTTP responses, for example, what does 1xx or 2xx means, you can just go to HTTP status playlist, in which I have defined all the HTTP status codes and described them as well. Coming back to our rate limiter, the next thing that we should discuss while designing rate limiter is how it would work in a distributed environment. For example, let's say there is one client 1, which you are serving on one continent of Earth, and there is another client which is being served from another continent. Now let's say they are using the same set of API keys or they are same user accounts. You will be counting their request number through some mechanism. In such cases, what you can do, you can store the increments or the variables for this particular client and this particular client in a centralized Redis database. Obviously, it would be a distributed Redis cluster, but this is the overall idea, like you will be saving this in a distributed Redis system. When we are implementing a rate limiter, monitoring is of the utmost importance because monitoring helps us in identifying the rate limiting algorithm effectiveness, and it also helps to improve the rules, or it also helps to improve the parameters of the implemented algorithm. Let's see how the whole architecture looks like. Now we have some client, and this client is requesting some information from the server. The rate limit middleware will check if this is rate limited or not. If it is not rate limited, it will forward the request to the API server, and from API server the response will be sent back. If rate limiter finds that this particular client is requesting on high frequency, it would rate limit it and it will send back 429 HTTP status code, which means too many requests. So here we are concluding our discussion of the rate limiter. The next steps that you should think about is how the rate limiting will be done on client side. Assume that you are working for a company which releases SDKs in different languages, and you can very easily implement rate limiting at that particular SDK side. And how you will do it on the API side? We have mostly discussed the gateway part of it, like how the rate limiting will be done on the gateway side. Okay, question time. Assume that you are working for a company which provides social login. Social login is something that we have seen, like login with Facebook, login with Google, or something like that. How would you implement client-side rate limiting? Assume that this particular social login will be used on browser and you can use local storage of browser to rate limit. Just develop a thought process and put it in words in the comments below. Obviously, I'm going to share the solution for this question in a separate video. Till then, keep thinking, keep designing. I'll see you soon with a new video.